Hi everyone, this is Richard Maddock, and I'm going to bring you a presentation on sentiment analysis. I want to give some historical context and the latest state of the art and some issues with sentiment analysis and how it compares to sentiment analysis as performed by humans. So just to start out, what we're talking about, generally sentiment analysis in the AI field refers to either negative, neutral, or positive sentiment or feelings or opinions, which is somewhat similar but not the same as emotional analysis, which actually classifies various emotions. And I'm giving you two of the most common classification systems: Ekman emotions and Palm's emotions, which are somewhat different. So both include anger, but Ekman includes disgust, fear, joy, sadness, and surprise as the six main emotions that humans experience. And then Palm's is anger, depression, fatigue, vigor, tension, and confusion, which is kind of interesting. But for the purposes of our discussion, we're going to focus just on negative, neutral, or positive feelings and opinions. Now, the goal, of course, of these AI systems of recognizing sentiment is to duplicate human judgments. Just want to point out that if you were to do some psychological studies about how humans judge sentiment in other people's speech or in other people's writing, you'd find an inter-rate of reliability of only about 80%. So humans are not perfect, and so we wouldn't expect the machines to surpass, I guess, the 80% accuracy that you find in human judges, simply because it wouldn't have, I guess, a meaning unless you could find some way to define what a higher degree of sentiment recognition than humans can achieve really means, which is another interesting question. By the way, I am a doctoral student in the psychology department, so this is an area of interest for me. Early historical development. The first systems were quite simple for sentiment analysis or sentiment recognition. They used dictionaries where you had a word associated with a certain sentiment. Some were positive words, some were negative words. This is an example of a dictionary used in a certain application. So killer, bounce, drag, those were negative words, while function, performance, groups were considered positive in this particular application. Going back, if I can go back here. Can't seem to go backwards. But you also had the development next after, simple dictionaries. You had the ability to link the words to the context of the documents or the sentence. So there were some systems of weighting the sentiment of the words depending on the context that they were in. One early system from around 2006, 2007 was an author named Snyder from MIT that was able to classify restaurant reviews. And what's unique about the system is that he used three different criteria in the restaurant reviews. So one was the atmosphere of the restaurant, one was the food, and one was the service, I guess. Don't recall exactly, but I think that was it. And So you had separate uh, scales for each, um, and they were linked. There was some dependency between those variables to some extent, and the system took those dependencies into account in coming up with a complete sentiment analysis for a restaurant review. And then you had the development of systems that used help from human judges to try to use machine learning algorithms to improve their analysis over time. So the humans would pitch in kind of supervised learning systems to help the machine over time. Later in around 2008, you had really an explosion going on in these years of media content online, and most significantly, Twitter tweets and online reviews, which made a system of ranking with stars and things like that for restaurants, for products, and so forth. And then also you had people expressing their emotions or sentiment through emoticons in their tweets or in Reddit reviews or some other communication. So that created a large data set, or pool of data sets that could be used and linked to sentiment analysis systems using the sentiment that was already evaluated there. So, with the machine could learn from what the humans had put down and understand what the context was of those reviews. So, for example, some guys from Stanford University took all the tweets in existence and had the hashtags of those tweets that had some sentiment or emotion associated with them, like surprise, like, oh, my friend just came over, surprise, hashtag surprise, or my friend told me I'm ugly, hashtag angry. So, you take that, and so these guys took all, it was like 1 billion of them, and were able to create some machine learning algorithms that were able then to use that information to classify new tweets, which was pretty effective and had very good accuracies. And don't remember exactly what, but it was good as I recall. The latest thing is multimodal, which is taking the sentiment analysis from your speech or your writing and comparing that and linking it to sentiment analysis from facial cues, which is quite good nowadays. They take the outline of like your lips, your eyes, the eyes going up like that. Is that surprise or is it angry looking? I was like an angry person, so I recently was in front of one of these facial recognition machines, facial emotion recognition machines. Just sitting there, it gave anger as an emotion response there. So it's quite effective, quite interesting. When you link these together, and also like your voice changes, the pitch changes, the tone changes, which is all part of what's called voice prosody. That linking together with your speech can create a very effective means of evaluating your sentiment, which can then improve the systems that exist there. Link that up with physiological data, which I'm going to show you in a moment. You can do with things like, one of those Fitbit watches that monitor your heart rate, your perspiration, conductivity of your skin, galvanic response, so forth. All of those things together provide an ample amount of data to understand emotions. So this has utility not just for sentiment analysis, but for understanding the psychology of human beings. So for me, it's a big motivation to get into this stuff. So like I said, you look at someone's face, you can get an idea of their sentiment. Humans do it well. Machines now can do it well as well. And link that up to natural language processing, algorithms, and you got a basis for some machine learning. Interesting that you could also use this to detect sarcasm, which is one of the challenges of natural learning natural language processing algorithms. Detecting irony and sarcasm is difficult for machines, but these kind of multimodal approaches give a way to do it. fMRI scans show different areas of brain activity. This is a particular picture from one study showing the response of the brain to two different coaching styles, one positive and compassionate, and one more fear-based and negative. So this is also in the area of physiological responses and can be used in study of sentiment. The brain has the capacity to generate emotion for almost everything that you're doing. You might be relaxed while you're studying or working. You might be stressed, or you might be angry, or you might be sad. And the things that you're doing and experiencing in your daily life have almost all an effect on your emotions in some way. So the aspect of language, which I find interesting, is that language so much is a response of the tongue to what's going on inside your soul at the moment. So do machines have a way to understand all that stuff that's going on, which is more in the bounds of emotional analysis, but it's tied into this work in machine learning and in AI that has to do with sentiment analysis. I find it a fascinating question. What is the ability of the machine to really understand emotion? Another distinction between the machine and the brain in terms of language and sentiment is that the brain interprets language. So you see something written and you have a picture of it in your head. The computer just relies on statistical linkages with, corpora of already established information. The computer is not interpreting language. So even in machine translations, you have just statistics basically going on with some help from AI to, get a phrase, and this is what most likely the phrase means in my own language, because this is what everybody translates it as in that context, which is nothing to do with really interpreting what the phrase means. So will this change in the future? That's a big question that I have. That's my presentation on sentiment analysis. I hope you enjoyed it, and thank you, Professor Wang, for the class.